All right, we'll continue now with topic number 10, which is circuit analysis with combination circuits. In the first part of this topic, we looked at some multiple choice questions from all public exams. Now we're going to look at some constructed response or part 2 items from all public exams. So just a very quick reminder, first of all, that the skills that we use to analyze circuits are Ohm's law, the current law, and the voltage law, developed by Kirchhoff. Then we have in series circuits, as this follows from the current law. Current is equal at all points because there are no junctions. And following from the voltage law, in a parallel circuit, voltage is equal in each connected parallel branch because that makes a full path. Okay, when you have series resistance, you just add them together. When you have parallel resistance, you do reciprocals. So 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 plus etc., etc. So let's take a look at some part 2 questions that have appeared on public exams over the past several years. So let's try this one. So we have a circuit. It's a combination circuit, obviously. And if you look at it carefully, you can see that there are 4 resistors, and most of the time they are numbered in a question. If they're not numbered, then you can feel free to number them yourself, and it doesn't matter which one you call R1, R2, or R3. It really doesn't matter. If they're already numbered, obviously you'd have to use the numbers that are there, but if they're not, what I generally do is start with current leaving from the battery, and the first resistor it comes to, that's R1. The next ones are R2 and R3, and the last one is R4. So what we've got here is a series resistor first, then I've got 2 parallel resistors, and then I've got another series resistor. And in this one, we're trying to find the resistance of R1. R1. So in order to do that, we're going to find RT first, because we know 2 things. Right? If we had drawn a table, we would have both VT, okay, this guy right here, this is VT, is 18 volts, and IT is 0.50 amps. So based on that, we can calculate the total resistance. V over I, so it's 18 divided by 0.50, which is 36 ohms. So now I know the total resistance is 36 ohms. And I know every resistor except for one. The only resistor I don't know is R1. So that should make it reasonably easy to find R1. Okay, we do it as follows. Okay, there's a number of steps here. First, we're going to find the parallel part. We're going to combine resistor 2 and resistor 3. So instead of writing it as 1 over RP and 1 over R2 and 1 over R3, the person who did these solutions, and I've taken these solutions straight off what's on the government website for the solutions to this particular exam, and they're all there for the taking. You can go ahead and grab them. Okay, instead of writing 1 over, they've written to the -1, which means exactly the same thing. And sometimes on your calculator, instead of saying 1 over x, the reciprocal button is actually written as x to the -1. It means exactly the same thing. So we plug in our 2 parallel resistances, which were 20 and 30, do the reciprocals, and we get this resistance right here, this parallel resistance, that is 12 ohms. So now I've got this, and this, and this are all in series now because the parallel resistors are gone. We've already combined them. So everything left is now in series. So the rest is easy. We know that the total resistance is going to be resistor 1 plus the parallel resistance, RP, plus resistor number 4. So we combine those. Here's what we get. 36, which was the total. We already found that using V and I. R1 is the only thing we don't know. Plus 12, plus 6. So work that out, and there's what you get. R1 has to be 18 ohms. So now we know all the resistors. Now we know all of the resistors. But there's other parts to these questions usually. Usually when you have a circuit question, there's going to be 2 or 3 parts. Okay, sometimes they'll ask you to find a missing resistor or a missing current or a missing voltage. Okay, and usually you will have to find something else first before you can do that. Okay, not always, but usually you'll have to find something else first. So in this one, another part of this question said the voltage drop across R2. So if we go back and look at our circuit, R2 is here. I want to know V2. I want to know what V2 is. Well, V2 and V3 are both the same. They're both the same. All right, so what I can do is I can use that parallel resistance if I want with the current that's coming through both of these resistors in total. So if I use the total resistance of that parallel part, use the current that's coming through it, which is a total of 0.50 amps, I can find the voltage. So here's what the solution looks like, and that's essentially what they've done. They said V2 is equal to V3, which is the same as the parallel voltage for that little section of the circuit, which is current parallel times resistance parallel. I already know those two numbers. I already know what IP and RP equal. IP is 0.50 because that's the total current going around the circuit. So yes, V2 and V3, or those two resistors I should say, R2 and R3, the two currents split up. But if I look at it as a whole combination, as a whole section, the total current going through the parallel section is 0.50 times the resistance of the parallel section, which I already calculated over here in part 1. Multiply that out and you will get the answer. And the answer is 6 volts. Okay, that's one way to do it. Now there are other ways. There are other ways. I could have, for example, found V1. Okay, I could have found V1 by saying I1 times R1 because I know I1 and R1. I could have found V4 by saying R4 times R4 times I4, or I4 times R4, whatever. And once I knew these two, one complete path around the circuit would be leave the battery, go through this resistor, then through this one, and then through this one, and then back to the battery. And I could have just done it then using Kirchhoff's voltage law. Same thing. Okay, it works either way. So if you're more comfortable doing it the other way, then by all means, do it the other way. It really doesn't make a difference. So like I said, we could have found V1, and I could have found V4. And once I found those two, remember that's I1 times R1, that's I4 times R4. Okay, and that, by the way, would have given me, if I go back and look, remember it's 0.5 times 18, so that would have been 9 volts. And the other one would have been 0.5 times 6, which would have been 3 volts. Then I could have said that VT is equal to V1 plus V2 plus V4. Right? This is an alternate solution I'm doing here now. And I could have said that VT was given as 18 volts. I could have said 18 is equal to 9 plus V2 plus 3. And that would have given me V2 equals 6 volts. Same answer, different method. Okay, both methods are equally correct. Doesn't matter which way you do it. Your choice. Let's try another circuit from a different exam. And like I said, you go to any of the old public exams, you will find one of these on every single exam. It's probably the one thing in the course that I can guarantee you will be on your public exam. There will be something there to do with circuit analysis. It's the one topic that we're positive is going to be there. So the current through the 5 ohm resistor. I want to know the current right here. Well, that's pretty easy actually, because look, here's a junction point. And remember, current coming down this way is 0.5. Current coming up this way is 1.5. So all you got to remember is current in equals current out. That's Kirchhoff's current law. So in other words, 0.50 plus 1.5 equals that current out. which means 2.0 amps is that current through that 5 ohm resistor. Just use the current law. That's it. Simple as that. That's not difficult. That's not difficult at all. And then the second part of this one asks us to find the resistance of R. The resistance of R. So let's go back and look. I need to know this resistance right here. Well, there's a couple of ways to do that one too. There's a couple of ways to do that one. One way to look at it, okay, one way to look at it is that if you look at the currents through each, I've got 1.5 amps through one of them. I've only got 0.5 through the other. So there's 3 times the current going through the 3 ohm resistor. That means that the other resistor, R, has to be 3 times larger than the 3 ohm. Okay, because 3 times larger resistance would only give you 1/3 of the current, which is what's happening there. So that's one way to do it. Okay, and you'll see the solution here done like that. Okay, VR equals V3. Okay, because they're 2 parallel branches. And V3 is I3 times R3. So VR is 4.5 volts. And then you can find the resistance by saying VR over IR. Okay, and that would be 4.5 over 5, or 0.5, sorry. That would be 9 ohms. So that's one way to do it. The other way to do it would be to figure out what the total current is, what the total voltage is, etc., etc. And you could work it out that way as well. But this is a much shorter way to do it, what's done right here. Much shorter. Then you're asked to find the potential difference across the battery. Okay, well, if we go back and look, we know what the voltage is for this guy right here. It was 1.5 times 3, which was 4.5 volts. I can find this one because it's 2.0 amps times 5, which is 10 volts. So one path around the circuit is this. Leave the battery, come up around, go down this way through this resistor, which was 4.5 volts. Then through this resistor, which we just said was 2 times 5, or 10 volts, and back to the battery. So 4.5 plus 10, 14.5. And if we look at the solution, that's actually the way it was done. See, they found the other resistor in the 5 ohm resistance was 5 times 2, or 10. Then they used the voltage rule, the voltage law. VT equals V5 plus VP. VP standing for the parallel voltage. And the answer is 14.5. Okay, so again, fairly straightforward. Okay, these problems are all very similar. Similar types of circuits every time. Okay, here's another one. We've got 4 resistors. I've got 2 series ones. These 2 guys here are parallel ones. They're parallel. So I want to know the voltage drop across R1. Well, in order to find the voltage drop across I1, I can do one of 2 things. I can figure out what all the other voltage drops are, and then use the voltage law. But that's not going to be very easy to do. So what I can do is, since I know all of the resistors, I can also find the total resistance first. And that's what we're going to do. We're going to find the total resistance first. So we do the parallel part first, which is 1 over 12 plus 1 over 8. That gives us a parallel resistance of 4.8 ohms, and you can see the marks that were assigned to each part of this. Then the rest is just series, R1 plus R parallel plus R4. So the total is 26.8. There's your total resistance. Now once you know the total resistance, now you can find the current. So you do the current by saying IT equals VT over RT. That's 2.99. And remember that the current now in resistor 1, because this is part of the series part of the circuit, whatever current leaves the battery has to be in this resistor as well. So 80 is the voltage divided by 26.8, the total resistance, gives you 2.99 amps. That also tells you I1, because they have to be the same. There's no split. So now, all I have to say is V1 equals I1 times R1, because remember, this guy here was also equal to I1 because it's in series. So 2.99 times the 12 is 35.9 volts. Done. That's the first part of that question. That's the voltage drop across R1. Like I said, there's usually multiple parts, so here's the second part to that question. The current through R2. Let's go back and look. R2 is right here. Okay, it's one of the parallel resistors. So probably the easiest way to find I2 would be to find V2 first. Because now that I know the current, I can easily find V4. If I know V1, and I know V4, and I know VT, I can easily find V2 because that's the complete path right there. The three of those resistors, the voltage drop has to add up to 80. So let's do that. Okay, first we find the voltage in the parallel part. Then we say I2 equals V2 over R2. Okay, that was a slightly different way to do it actually. The other way, okay, the other way that I mentioned was to find V4, which would be I4 times R4, which would be 2.99 times the other resistor, which was 10, which would be 29.9 volts. Then I could say this. I could say that VT was equal to V1 plus V2 plus V4, which meant that, if we go back and look, it was 80 volts equaled V1, which we found in the first step, which was 35.9 volts. 35.9. Okay, V2 we don't know yet, but we do know that V4 is 29.9. So that would give you V2. Okay, that would give you V2. And V2 would be 14 volts approximately. Actually, it's about 14.2. Okay, volts. And then you could say I2 equals V2 over R2, and you still get the same answer. Just a slightly different way to do it. Like I said, there's more than one way to solve these problems. It's never just cut and dry. You got to do it this way, you got to do it that way. There's always 2 or 3 possible routes you can take to get to that final answer. Let's do one more before we stop. Another combination circuit. First thing we're asked to do is calculate the total resistance. So I've got to combine the 2 parallel ones first, and then add that to the series one. Now if you like, you can do all that in one step. But what we've done here is R parallel equals 1 over R2 plus 1 over R3 to the negative 1. And that gives us this for R parallel, which is 6.7 ohms. Then once we know the parallel resistance, all we got to do is add it to R1, and we get 11.7 ohms. Okay, that's pretty straightforward. That's pretty straightforward. Probably worth a mark. Then the second part of this question says to calculate the voltage across resistor 2. So we go back and look at resistor number 2 right here. Okay, this guy right here is resistor 2. Well, what we can do is now that we know the total, or now that we know the total resistance and the total voltage, we can find the total current, which is equal to the current in this part, and we already know the resistance of that part, and we can use that to find the voltage. Or we can find the voltage in this one right here, V1, and say VT equals V1 plus V2. You'll get the same answer either way. You'll get the same answer whichever way you do it. So total current leaving the source is the current moving through the parallel part. So current in the parallel is V over R. Okay, 120 over 11.7. And then since R2 is part of the parallel part, then V2 equals the voltage parallel, which is IP times RP. And there you go. There it is. Okay? That's one way to do it. Like I said, the other way to do it would be to find the other V first and then use the voltage rule or the voltage law. Either way, it doesn't matter. Okay? They're both equally correct. And you get the same answer either way. Now, determine whether the fuse will blow. Now that's an interesting question. How do you know whether a fuse blows? Well, if we go back and look at our diagram, this was a 4 amp fuse. So that means if more than 4 amps go through this part of the circuit right here, the fuse will blow. If less than 4 amps go through that part of the circuit, the fuse won't blow. Well, we already know that the total current is 10 amps. Total current is roughly 10 amps. But that's the total current in the circuit. When that 10 amps gets here, it splits. Some goes this way, some goes that way. So we actually got to figure out exactly how much goes that way. Well, since we already know the voltage, we can easily find the current, right? R3 is part of that parallel. So in other words, the voltage drop for resistor 3 is the same as the voltage drop for resistor 2, which was 67 volts. We just found that in the previous part. So I can say I3 equals V3 over R3, 67 over 40, or 1.7 amps. Now remember, it was a 4 amp fuse. So 1.7 amps is less than that 4 amp fuse. Therefore, the fuse will not blow. It will only blow if the current goes above 4 amps. And in this case, it's not. So the fuse doesn't blow. All right, now, the fuses are used as a safety feature. It's a good time to mention this. It's a safety feature to prevent too much current from going through a circuit. So because of that, if the fuse blows, that tells you that there is too much current going through. And the reason fuses are there is as a safety feature to prevent extra current from going through, because if too much current goes through the circuit, the wires can get hot. And in your house, that can cause the wires to catch on fire and therefore your house to catch on fire. So those fuses are there to prevent that from happening. So it's very important that if a fuse blows, you don't replace it with a larger fuse. That's not the answer. If the fuse blows, that tells you there's something wrong. That tells you that the circuit is overloaded. And overloading a circuit can cause the circuit to overheat. And when a circuit overheats, there's a risk of a fire. So never ever do that. So that concludes the circuit analysis of combination circuits. Now there's only a couple of minor things left with the electricity part of Unit 2. And we're going to cover that in our next lesson. Okay, our next topic, topic 11, where we'll cover the concept of electrical power and the cost of buying electrical energy. So we'll look at those in topic 11. So as I always say, good luck with your exam. Keep studying. Okay. Be sure to check back for the newest topics that are being covered, because we're more than halfway through the course right now. So until next time.